of undetermined coefficients. This method is used to find particular integral of linear differential equation with constant coefficients, provided this differential equation will be non-homogeneous. On account of the function q, on account of this q function, this differential equation is non-homogeneous, and the a1, a2, these will be constants. Both of them will neither be function of x or function of y. Moreover, this differential equation will be linear. Here this q, where q of x is a function of x, a1, a2 are constants. The solution depends on the function q of x, and accordingly we take a function called the trial solution. The question is to choose the correct form of trial solution, and this trial solution is the generalized form of the function q of x. Must be careful during choosing the trial solution. Now we nature of function q. If q of x is a polynomial, that is, if q of x is equal to, if function q is equal to this thing, ax square plus bx plus c, if this is and this is not 0, we are crossing this 0. If this function q is ax square plus bx plus c, here we have quadratic, this function is quadratic polynomial function, then the trial solution will be the generalized form of function q. This will be the trial solution on account of function q. Since here we have quadratic function, so the trial solution will be the generalized form of the above quadratic function. Here we have used constants c1, c2, c3. Do not take constants which were used in yc. Since this differential equation is non-homogeneous, this differential equation is non-homogeneous. For the complete general solution, first of all we have to find out the complementary function which will have two constants. So we must be careful while writing the trial solution. We will not write those constants which were used in the complementary function. Here I have written, do not take constants which were used in the complementary function. This yc is the complementary function. So this is one point. In this point, if function q is quadratic, then we have to generalize it, and we will take this function as our trial solution. We will take care of the constant. We will not use those constants which we see in the complementary function. Now we come to the second point. If function q have a sine function or cos function, that is, if q of x is equal to a sine of 2x or a cos of 2x, or if function q is the sum of these two functions, then the trial solution will be y is equal to c1 sine 2x plus c2 cos 2x. Take both of them and trial solution. Whenever we have a function q in the variable x having either sine or cos or both the function, then we must take both the function in the trial solution, in the corresponding trial solution. So we must remember this point about this sinusoidal function. If we have either sine or cos or both, then in the trial solution we will take both of them. Now we come to the next point. Here we have another point 3. If q of x is equal to a e power 4x, here the right hand side function q is a e power 4x. This is our right hand side function. Then the trial solution will be y is equal to this one. This is the given function q. This is the function lying to the right hand side of the differential equation, and this is the trial solution which we have to use. Here this trial solution is the generalized form of the function q. This trial solution is the generalized form of function q. Here we have the constant c1 and we have to determine this c1. So we should remember, if the function q is exponential, then for the trial solution we have to take the generalized form of the exponential by using a constant, either capital A, capital B, or c1, c2, and we have to determine such constant. Point 4. A part of the function in complementary function yc. This is this yc represent complementary function. It is the solution of the associated homogeneous differential equation, and q of x is the function lying to the right hand side of the differential equation. A part of the function in complementary function yc and function q is same. That is, if there is some similarity in y and q, then multiply that part in the trial solution by the lowest exponent of the variable x, so that it becomes different from the one in yc. Whenever if we see any term in yc and if that term also belong to q, then during generalization of q, to choose our trial solution, we will multiply that term by the lowest exponent of the variable x or t, whatever we have in function q. So we must remember this point 4. Suppose we have the trial complementary function. This is our complementary function, and if it also belong to q of x, then take trial solution as, if q of x has the term e power 3x. This is our complementary function, and suppose function q have e power 3x. Here this is e power 3x, which is also a term of the complementary function c1 e power 3x. Here we have similarity in the complementary function and in function q. Then include, now we have to choose our trial solution having this situation, then include this term in the trial solution as c3 e power 3x. Here we have e power 3x, which is also in function q. So to make it different in the trial solution, we will multiply e power 3x by the lowest exponent of the variable x. So this will be the required trial solution. This is our required trial solution. This will be the trial solution. Now our trial solution will be this one. This will be our trial solution. This trial solution is a function which is different from e power 3x and c1 e power 3x. Here one point must be kept in mind. Here in the complementary function we have constant c1 c2, and in the trial solution we have chosen another constant, and our aim is to determine this constant c3. Here we have multiplied e raised to the power 3x by x to make it different from that of yc. So we have to remember point 4. In the point 4 we see that if any term in yc and in function q are similar, then we have to multiply the generalized form of function q by the lowest exponent of the variable x. Now we come to point 5. If we have two similar terms in complementary function and q of x, point 5 is similar to point 4, but in point 5 we are discussing about sinusoidal function. Suppose sin 5x, if we have two similar terms in complementary function and function q, Suppose both the suppose CF and Q have sine of 5x, then we have to take our trial solution as our trial solution will be this one. To choose the trial solution, we must use sine and cos both, because we have sine function in Q. Whenever function Q have either sine or cos, then we must include both of the trigonometric function in the trial solution. Now here we have x. This x, the purpose of x here is to make it different from the similarity lying between CF and Q of x. If we have two similar term in CF and Q, suppose that similar term is sine of 5x, then we have to take our trial solution in this way. So these are the 5 points and we must remember them. Now we come to the next slide. Here we have a summary of the method. In the screen we see ay double dash plus by dash plus cy is equal to g of x. Here we have a non-homogeneous second order linear differential equation with constant coefficient a, b, c. A, b, c are constant coefficients. Now the general solution of this second order linear differential equation will be it will be y is equal to yc plus yp form of g. Now this table here we have the entries lying to the left hand side and entries to the right hand side. The left hand side represent function lying to the right hand side of the differential equation. The entries lying to the right hand side are the generalized form of the function g of x. This generalized form is our trial solution. Now we read form of g of x. These function are forcing function. These function are forcing function, and form of yp. This is our trial solution. Here we have our trial solution. If our function g is constant, then in our trial solution we will simply generalize this constant by using a. This a represent constant. It is our trial solution. Linear polynomial. If our forcing function g is linear polynomial, that is of degree 1, then we have to generalize our linear polynomial by ax plus b, and it will be our trial solution. Quadratic polynomial. If we have forcing function quadratic polynomial, then our trial solution will be ax square plus bx plus c. Cubic polynomial, our trial solution will be this generalized form of cubic expression. If we have either sine or cos in our forcing function, then we must use this expression as our trial solution. If we have the forcing function e raised to the power ax, this is the exponential form, then we will take its generalized form ae power ax, and it will be our trial solution. So we must remember the two columns. This is here we have forcing function, and here we have corresponding trial solution. In these trial solution, our purpose is to determine the unknown constant, that is the undetermined constant. On the screen we see the non-homogeneous linear differential equation with constant coefficient. This differential equation is of order 2. So for the solution, find the complementary function first. Take the trial solution, but do not take part, that is root of auxiliary equation, which are in q of x. In this case, multiply such part by the lowest degree variable x. In point 2, we have been The purpose of point 2 is we have to take the generalized form of function q. If there is some similarity in complementary function and function q, then we have to multiply the generalized form of function q by the lowest exponent of the variable x. 3.3 differentiate the trial solution y to find the first order and second order derivatives and put in the given differential equation. Equate like terms on both sides to find the constant in trial solution. Put all values of the constant in trial solution, which will give the particular integral yp. For the general solution of the second order non-homogeneous linear differential equation, find y is equal to yc plus yp. So this slide is the guideline about the solution of the non-homogeneous linear differential equation of order 2 by the method of undetermined coefficient. Now we have point 6. These are this is point 6. We saw point 1, 2, 3, 4, 5, and this slide have point 6. If the auxiliary equation or characteristic equation has double root 2, then the complementary function is. If the characteristic equation of the homogeneous differential equation has two double root, two similar root, then the complementary function will be equal to y is equal to c1 plus c2x e power 2x. Whenever we have double root, we have to put here constant c1 plus another constant multiplied by x into e power 2x. This 2 is the double root of the auxiliary equation corresponding to the associated homogeneous differential equation. This is our CF. If q of x has e power 2x, if we have function q with e power 2x, this e power 2x also belong to q, and e power 2x is also belong to the complementary function yc, then take the following in trial solution. Above here we have point A, point B, point C. So should we take in trial solution the term this one? Here we have e power 2x in function q, and in yc. To make it different, should we multiply e power 2x, this generalized form of e power 2x, by what? Should we take e power 2x as it is or we have to multiply by x or x square x cube? So here we have a question, should we use this for our trial solution? Here we have c1 e power 2x, so we cannot take c1 e power 2x in our trial solution. Similarly, we cannot c2x e power 2x in our trial solution. To make it different, we have to multiply x by another x. Thus the trial solution will be c3x square e power 2x. Maybe yes, we can take, if e power 2x both exist in yc and q, then to make it a little bit different, we have to multiply it by x square. So this is our trial solution. If we multiply by x with this expression, can we take in trial solution this one? Is it correct to take it for our trial solution, this one? It's not correct, because x e power 2x, this here we have x e power 2x, x e power 2x, so this x e power 2x is in yc. This term belong to yc, so we cannot take this multiplication as our trial solution. The first one is correct, the second one is incorrect. Can we take in trial solution x square c3 plus c4x e power 2x? Yes, this is also correct. This is also correct. In this yc we have e power 2x. Similarly, e power 2x also belong to q. To take our trial solution, we must make it different. So we will either multiply e power 2x by x square, or we have to multiply this expression by x square, and it will be our trial solution. In the few question we have used this one. Now we come to the next slide. Here we have an example. D square y minus 4y is equal to e power x. This is a question. This is e power x plus sine of 2x is the function q of x. It is a second order linear differential equation with constant coefficient. Here we have coefficient 1 which is constant. Here we have coefficient minus 4 which is constant. Now we have to write the associated homogeneous differential equation by putting the right hand side equal to 0. So this equation is associated homogeneous differential equation. By omitting y, this is our characteristic equation or auxiliary equation. Solving this equation, d is equal to 2 or minus 2 are the roots of auxiliary equation, or this and this e raised to the power, this 2 will be e power 2x, which will be the solution of homogeneous differential equation. This minus 2, which is the root of auxiliary equation, this minus 2 will exist as e power minus 2x as the root of second root of homogeneous differential equation. If we multiply any solution of homogeneous differential equation by a constant, that will also be the solution of homogeneous differential equation. So this is one solution of homogeneous differential equation, this is another. Their sum will also be the solution of associated homogeneous differential equation. Here we have used 2 minus 2 in the complementary function. Now we have to choose our trial solution. This 2 which is in the form of e power 2x, here we do not have e power 2x. Similarly, minus 2 in the form of e power minus 2x, we do not see e power minus 2x here. So there is no similarity between function q and yc. So we have to generalize this side. We have to generalize e power our function q. We have to generalize our function q for our trial solution. E power x will become, we have to take e power x. Since we have used constant c1 c2, so in our trial solution we will take c3 e power x, c3 e power x. Here we have sine function and the function q. Whenever we have either sine or cos, we have to take both of them in our trial solution. So in the next slide we will see our trial solution as c3 e power x plus c4 sine of 2x plus c5 cos of 2x. The trial solution is this is our trial solution. On account of sine, we have included both sine and cos in our trial solution. On account of e power x, we have used c3 e power x in our trial solution. Here we have used c3, c4, c5 because c1, c2 have already been used in yc. Now this is our trial solution. This is our trial solution, and further then find dy, first derivative of this equation, second derivative of this equation. Then put in given differential equation and equate the coefficients on both sides to find the constant c1, c3, c4, c5 in the trial solution, and thus we find particular integral yp. We will differentiate this y with respect to x to get y1 or y dash. Then we again differentiate to get y double dash. We will put value of y dash, y double dash in the differential equation. We will equate both the sides to find c3, c4, c5. Then we will put value of c3, c4, c5 in this equation, in this equation, which will be our particular integral yp, and this will be the general solution of the given differential equation. This will give us the general solution of the differential equation. So in these two slides, first of all we solve the homogeneous differential equation and found our complementary function. Then we choose our trial solution. This trial solution has to be differentiated twice, and the aim of the solution is to determine C3, C4, C5, and finally we will reach to the general solution. Now we come to the next slide. Here in this question, here we have another question. This is a differential non-homogeneous differential equation. Here we have function q equal to x plus e power x. This is our function q. The associated homogeneous differential equation corresponding to this non-homogeneous is this. This is our this is our homogeneous differential equation. This is another form of the above equation. This is our auxiliary equation. These are the roots of auxiliary equation or characteristic equation, and the below expression will be our complementary function. This e power x is the double root. This one is the double root of characteristic equation. 1 is the double root of characteristic equation, and e power x is the double solution of the associated homogeneous equation. Now we have to choose the trial solution. Their trial solution will be the generalized form of function q. This is our function q. Now looking to this function q, there is similarity of e power x. Here we have e power x, similarly here we have e power x. So while choosing the trial solution, we have to generalize function q, and we have to make e power x a little bit different, because e power x lying in function q and yc. This x is a linear function. Whenever we have linear function in function g, which in function g or q, it is our forcing function. It is part of our forcing function. It is linear, and we have to generalize. So generalized form of x is c3x plus c4. Since c1, c2 are here, we have to use other constant c3, c4. So c3x plus c4 is the generalized linear form of this linear expression. Now e power x, we have to generalize e power x by using constant c5 and by multiplying above. Now we have to multiply here. Looking to complementary function, e power x is here multiplied by x, so we will not use here x e power x, but we will take x square into e power x. Here we have to take x square e power x. We cannot simply take c5 e power x, because we have c1 e power x. On account of c1 e power x, we cannot take c5 e power x. On account of c2x e power x, we cannot take c5x e power x. Thus, to make it different, we have to take c5x square e power x. Here we have x, so here we have 1 degree more, which is x square. This is our trial solution. This is our trial solution. Now from this trial solution, find first and second derivative of trial solution and put in given differential equation to find out the unknown constants of trial solution. Then put them in the trial solution to find out the particular integral yp. Finally find the general solution by using this equation. This will give us the required general solution. Now we come to the next slide. Here we have another question. This is a second order non-homogeneous linear differential equation. This is the corresponding homogeneous differential equation. This is the auxiliary or characteristic equation. These are the roots, and these roots will exist as e power x, e power minus 6x in the complementary function. This is our complementary function. The trial solution is, now looking to the question here, e power 2x. Here we do not have e power 2x. This is not e power 2x. This is not e power 2x. Or if we take this 2 is not here. This 2 is not here. So we do not have any problem during selection of trial solution, since e power 2x does not belong to here. So we have to generalize this function for our trial solution. Thus the trial solution will be y is equal to c3 e power 2x. This is our trial solution. Differentiate twice. Find first, second derivative of trial solution and put in given differential equation to find out the unknown constant of trial solution. Then put them in trial solution to find out the particular integral yp, and finally this will be the required general solution. Now we come to the next slide. Here we have a question. Solve this. Already we have discussed this question, but we have to discuss a little bit more. This was the question which we discussed in our previous slide. For this differential equation, this is the characteristic equation whose roots are 1, 1. 1 is the double root. This is the complementary function. This 1 we have 1 is the double root, so this is the complementary function. Now for yp, the trial solution, what will be our trial solution? Now for yp, the trial solution will be taken by using its rule, and care should be taken not to take part of trial solution similar to that of yc. That part of trial solution and yc be different. I have enclosed these sentences in bracket. Do not use these while solving the question. Here we have double root. 1 is double root of the auxiliary equation. This is the complementary function. E power x is here. Similarly, e power x is here. So we have to generalize this right hand side for the trial solution. This x will become c3x plus c4. This e power x on account of c1 ex, c2x ex. This e power x will become c5 x square e power x. So this is our trial solution, which we have already discussed. Now we have to differentiate y with respect to x first time, second time. Putting all these values in the differential equation, we get value of c3, which is 1, value of c5, which is 1 over 2, value of c4 is 1 over 2. Here you see values of here we have put the value of y dash, y double dash in the differential equation, and by equating both sides we have value of all the unknown constant. Then we have to put these value. Here we have value of c3 is equal to 1, value of c4 is equal to 2, value of c5 is equal to 1 over 2. Putting these value in the trial solution, thus the particular integral yp is equal to this one. This is our particular integral. The complete solution is y is equal to yc plus yp. Putting the value, hence this is the required general solution. Now we see our next